Hello everybody, thank you for watching. This is our 9.6 video on Boyle's law. In this video, you're going to investigate the relationship between pressure and volume using Boyle's law, and then be able to solve calculation problems that involve pressure and volume. Let's talk about Boyle's law a little bit. This is an image of Robert Boyle, and what he did was he described the relationship between pressure and volume of gases. He determined that for the same amount of gas at constant temperature, we have an inverse relationship between pressure and volume. So what that means is if pressure is going to go up, then our volume is going to go down. Or the opposite version would be if pressure goes up, then our volume will go down, or vice versa. Right? Using Boyle's law, we have a specific formula that I need you to remember. The formula is P1 V1 equals P2 V2. And the P stands for pressure and our V stands for volume. So the one little subscripts represent our initial pressure and our initial volume. The 2 represents final pressure and final volume. If we take this formula, we should be able to calculate problems relating pressure and volume. So let's take a look at this example problem. It says a sample of helium gas is compressed from 200 milliliters to 0.24 milliliters. The pressure now is 3 atm. What was the original pressure of the gas if the temperature remains constant? So what you need to do is read this problem and be able to plug in values for either P1, V1, or P2 or V2. It says a sample of gas is compressed from 200 milliliters to 0.24 milliliters. And milliliters is a unit of volume. It's telling us that the pressure is now 3 atm. So our formula is going to look like this. We are solving for P1 because it says what is our original pressure. And our V1 is 200 milliliters, and that's going to equal 3 atm multiplied by 0.24 milliliters. In order to do the math, since it's an equation, we're going to multiply 3 and 0.24 and then divide 200 milliliters in order to get a P1, which is our initial pressure, of 0.0036 atm. Let's take a look at another problem. It's hard to begin inflating a balloon. A pressure of 800 kilopascals is required to initially inflate the balloon to 225 milliliters. What is the final pressure in atm when the balloon has reached its capacity of 1.2 liters? A hint for this problem is make sure you're changing your units so your units are the same. Right now, we have something that looks like this. We have kilopascals, milliliters, and liters. So you want to make sure that your units are the same when you're plugging it into the formula. So pause the video and try to change liters to milliliters and solve this equation and make your final pressure in atm using our pressure conversions. So what we're going to do is we're going to change 1.2 liters and turn that and convert that into milliliters. So we have 1200 milliliters. When we do the math, we have 800 kilopascals multiplied by 225 milliliters divided by 1200 milliliters, we get a P2 of 150 kilopascals. It wants our final pressure in atm. So now we need to convert kilopascals using our conversions into atm. When we do that, we're going to get a final answer of 1.48 atm. And that concludes our video for today. Thank you for watching.